80 days. That's how long it takes on average to process DNA evidence from a sexual assault crime. 80 days. Imagine the helplessness that victims feel while they wait up to 3 months to find out if their attacker might be brought to justice. There are many reasons for this delay, but it ultimately comes down to the large number of samples that need to be tested and the difficult protocols required to extract DNA evidence that can be used in court. Now, what makes those protocols challenging is that sexual assault samples contain many different types of cells, usually from at least 2 different individuals. And before you can conclusively identify a suspect, you have to completely separate the DNA of the attacker from that of the victim. Now, to do this currently, highly trained analysts will manually wash and centrifuge each sample, slowly purifying and collecting sperm cells from the rest of the genetic material. This is effective at collecting DNA from only the attacker, but it requires high levels of precision, several hours per sample, and can be prone to contamination. So the goal of my research is simple. I want to develop an automated technique that can collect sperm cells from sexual assault samples and do so faster, more reproducibly, and with less chance of contamination than a human analyst. To do this, we've used microfluidic chemistry, which is basically just the manipulation of liquids and particles on a very, very small scale. This approach allows us to avoid the repeated spinning and washing steps of traditional techniques and instead capture sperm cells using sound waves, forming a compact pellet that's easy to extract. Think of the way a river flows around a rock. That rock is a pellet of sperm cells being held in place, while the river washes away any other DNA or genetic material that could lead to an inconclusive DNA profile. We can achieve this selective type of trapping by applying a high-frequency vibration through a liquid sample, which generates low-pressure regions at each intersecting point in an acoustic wave. When we then inject a mixed sample of cells through this acoustic wave, the sperm cells are held in place and trapped at each intersecting point, while everything else is washed away. We've tested this technology extensively, using mock samples from the UVA hospital, as well as real sexual assault samples from the Palm Beach County Sheriff's Office in Florida. At that forensic lab, I trained their analysts to operate our prototype instrument, and we tested real sexual assault kits from over the last decade. In one instance, we successfully captured sperm cells from a 9-year-old piece of evidence, and the resulting DNA profile exactly matched that of the confirmed attacker. There are still many improvements we can make to this technology, but we're hopeful it can soon be implemented in labs around the country. And with over 100,000 sexual assault samples still waiting to be tested in the US alone, any improvement we make to this process is a necessary step towards justice for victims of these crimes. Thank you.